Dear students, today we are discuss about the Mosfet depletion Mosfet. So in previous video we discussed about the FET. Now basically FET is the two parts. One is the JFET and another one is the Mosfet or insulated gate field effect transistors. Now as here so, MOSFET is the metal oxide semiconductor field effect transistors, basically two types. One is the depletion mode and another one is the enhancement mode. Now in depletion mode, same way in FET it says N channel and P channel, same here is the N channel and P channel, also enhancement is the N channel and P channel. So today we discuss about the depletion mode. Is basically symbols is given. What is the difference here for the symbolically in FET or in depletion type MOSFET? Here is the two line is draw. One is the gate and this line and this line, between this we are separated. So here is the insulations is provided between these two. These are the major difference between the FET and the MOSFET, and one additional terminal is the substrate. Now we see here depletion type, it's require gate source voltage. It means voltage between gate and source such like that is behave like a switch device off. It means is a normally closed switch behave like this way. In enhancement mode requires gate source voltage VGS to switch device on, and this is normally open switch. Now we here in this video we discuss about the depletion mode N channel and depletion mode P channel MOSFET is construction and working. So here N channel depletion type MOSFET, here is the construction. Now as shown in the figure, we take two N type material semiconductor material and P type semiconductor material. P type semiconductor material consider as a substrates and terminal is SS, and N type material is one is a source and one is a drain. In between these two, the closed conductive channel is available is the N type, and one is the gate terminal. Now in this, here is a very thin layer as the insulation is imparted between gate and substrates is silicon dioxide. So here as is a source, G is a gate, D is a drain, SS is a substrates. Now we want to discuss about the working of MOSFET of a depletion type. So here we considering two cases. In first case, suppose we are given a VGS is equal to 0. It means no voltage is given. It means a gate to source is a ground, substrate is also to be ground. So this our terminal is a grounded with respect to this way. So here voltage is 0. So now when the voltage is given between the drain and source, at that time drain is connected to positive terminal of the battery and negative terminal to source. Now we know that in the N channel the majority charge carrier is electrons. So numbers of electrons here is attract here is the positive terminal of the battery or source of VDS. So flow of electrons is such like that, it's called natural current flow due to electrons, and the conventional current flow to positive to negative is called drain current, is called IT. So this way VGS is equal to 0. It means that when gate voltage is not given, at that time IT current can be increased. So VDS is increased, then current is also increased up to the majority charge carriers available in the channel. Now in case 2. Now in case 2 we are considering the voltage is negative. It means that VGS is equal to less than 0. It means gate terminal is negatively given. So upper portions of the gate is negative. So as we know, the capacitor having two terminal or two conducting plate between its insulation media. So if here is a negative terminal charge, so here is the positive terminal charge. So like that construction, same here, these are the insulation is SiO2 upper side is the gate, is the negative. So and the bottom of this is the n channel. So majority charge carrier in n channel is electrons, and P is the substrates. Here is the majority charge carrier is holes. Now due to that negative effect of the gate terminal voltage, the electrons in the n channel are repelled from this and holes are attracted this way. So in between this n channel, these holes and electrons are recombination processes start. So recombination processes start. At that time what happen? These free electrons, numbers of free electrons in n channel, which are the current flow through drain to source, will be reduced. So electrons repelled by negative potential of gate and holes are attracted to the negative potential of the gate. So these recombinations of that charge carriers is reduced, free electrons is reduced, so ID is decreased. So here as shown in graph, ID versus VDS. So here when VDS is given, so starting it will be increased sharply like ohmic region, and then after saturated and fixed, the constant current can flow at the time of VGS 0. Now if voltage VGS is decreased, it means negative, then gate voltage is negative, then ID will be decrease. If gate voltage is positive, then it will increase. So this way we can discuss about the n channel depletion type MOSFET. Now second one, same way, P channel depletion MOSFET. Difference is that here is substrates is N instead of P and channel is P instead of N. So sorry, we can also the supply voltage between drain and source will be reverse. Here is the negative and the positive. So what happen if here is the majority charge carrier is holes, and these holes are attract this way, so holes current will be flow this way. So if we are considering the case this is a 0, VGS is equal to 0 at that time. Now in considering the voltage VGS is positive, so here is the positivity is increased, so upper side is the positivity is increased. Due to that P type material, P type channel is the majority charge carrier is holes, and the N substrate is majority charge carrier is electrons. So same way happened when what in the N channel, same way happened in the P channel. The recombination process, holes and electrons are here, which reduce the free holes which are flow from drain to source will be reduced. So same way, if VGS is a 0, then current will be sharply increased, and then it will be stop ID and then constant. So these are the value. If the voltage positively is increased, then drain current is decrease. So at that time when the start with the saturation mode, at that voltage is called as a pinch off voltage. So in these two cases we see that the graph will be so that current will be flow due to the gate voltage and controlled by the gate voltage. So this way is the MOSFET will be working in a depletion mode. So next video we are discuss about the enhancement mode in N channel and P channel. Okay, thank you. Dear friends, now in this video we are discuss about the enhancement mode type of the MOSFET. Now in our previous video we have discussed about the depletion mode type of the MOSFET. Now what is the difference in these two types of MOSFET? Now here is the no channel between the drain and source. It means what? There is a no channel will be here available as depletion mode is available. So here is the no channel between drain and source. So this channel will be created by using this gate terminal. So this is the enhancement of this channel here in between source and drain. So that's why it's called the enhancement mode type the MOSFETs. Now we discuss here for the N channel. So N channel having here is the P is the substrate as a base, and two N type materials using semiconductor devices for the source and drain. So here gate are the isolated with the using of SiO2, same as the depletion mode. Now here is the condition is that when VGS is a 0, it means gate to source will be the grounded. It means no voltage available at the gate. It means VGS is equal to 0. That's why we call that it is in the off condition, because there are no channel available in between this. Now what happen when we given the voltage between the gate and source voltage? So here we are given the positive voltage VGS will be the increase here. So this positivity charge will be increased in the upper side of the gate. They are not cross to the substrates, because here is the insulating media, or SiO2 layer is here. Now at that time we are still not given the drain voltage with respect to source. So what happened? At that time then VGS is positively increase, so positivity is here increase. So here is the bottom side is the P substrates having a majority charge carries the holes and minority charge carries the electrons. So holes are repelled to the bottom side, and the minority charge carriers electrons are go upwards to the gate side, but they do not cross this because of this insulating layer. So these electrons are deposited here. The number of electrons are more deposited here depends on the value of the gate voltage. So these electrons is deposited here and create a layer. It's called as the inversion layer. So at that time when the inversion layer is created, this is called, that voltage of VGS is called threshold voltage. So when VGS is increasing, the threshold voltage at the value of VGS create the channel. So this is created by the electrons are here is the N type. So this way we create the channel. Now VGS is increasing. At that time here is the N type material, and with respect to this P type material make a junction. So both are junction. Here we show that the reverse bias junctions. So here is the depletion width is to be created. So this way we consider that when the voltage is not given, these are in the off conditions, and when the voltage is given, the channel will be created. Now VDS is applied between the drain to source. Here now we are applied between these two terminal. The voltage is applied positive terminal with respect to here. So positive voltage is to given here in the drain terminal. So that's why here the reverse bias is increase. So depletion width will be increase. Due to that what happen? The depletion width will be increase. So here is the numbers of electrons will deposited will be decrease. So here the area will be decrease with respect to source. So here is the sharp is decreasing at the upper drain side. So more reverse bias, so size of channel is reduced. Now further we are increasing the voltage of VDS. So what happen? There are condition is available here is that no current can be flow from this source or drain in between these two. Because of this condition is available here is pinch off condition. So these are from that. Here is the electrons are going through here through channel, and the force of electrons they are going there this way is a saturated condition. So current will be constant. So as shown in the graph we can see that here is the VDS versus ID. So when we are increasing the value of VDS, so they are sharply increase the value of ID with respect to voltage between gate and source. So if the voltage is the VGS, it will decrease, the ID will be decrease. So now this graph is created three region. So these are the saturated local curve will make this area will behave like a voltage control resistors. So in this region the MOSFET will be work at the voltage control resistors, and this is called as the ohmic region. And in this way these are the saturated point and that point start the ID will be decrease or stop, and this constant. So these all the regions is saturated regions, and when the VGS is equal to VT threshold voltage, their voltage will be is called the threshold. This is region is the cutoff region. So this way the region will be operated. This graph will be same as the depletion mode MOSFET. Now same way here for the P channel. So P channel is here, instead of P here is the N, and VGS is 0. So here is the channel will be created when the voltage will be given is the here terminal is the reverse, the negative terminal voltage here, the negative charge will deposited in the upper side. That's why the positive of the minority charge carrier of N substrates will be deposited here, and that's become make a channel. So that's the same way here will be more VGS will be increasing, and then this is the pinch off condition is there. So here is only change is there, the voltage will be minus, and when the voltage minus will be as shown figure, will be curve will be we get the results. So this way we can discuss about the enhancement mode type as a P channel as well as the N channel. Thank you.